Hello, everybody. My name is Kati Verheyen. I'm Senior Project Manager at MECLA, the Materials and Embodied Carbon Leaders Alliance. I would like to welcome you today to another one of our MECLA Spotlight events. Today, our speakers will be showing us how to deviate. In particular, how to use the deviation process to accelerate the uptake of low embodied carbon materials in constructions. Before we get started, though, I would like to acknowledge the traditional custodians of the lands on which we meet today. For me, that is the land of the Gadigal peoples of the Eora Nation, and I would like to pay my respect to elders past, present, and emerging. I also want to extend that respect to any Aboriginal and Torres Strait Islander peoples here today. Today we have over 200 registrations, and I just had a little sneak peek who's joining us today, and it's certainly a very diverse representation across industry, government, and research. We have material manufacturers, contractors, asset owners, a lot of infrastructure asset owners, but also for commercial buildings. We have representation from government agencies, standards and specification setting bodies, local councils, actually a lot of local councils, and best of all, we have people represented from across the country. It's not just New South Wales, ACT, Victoria and Queensland, but it's also WA and Tasmania. So I would like to welcome you all to this meeting today. As you all know, MECLA works from within the government's framework that ensures we are in a pre-competition environment. The Q&A function is active, so you can put any questions that you have during the presentations in there. We will have a panel session after the presentations where we can look at that. And please do use the chat function if you need to for any or wish to for any additional comments. We are recording this event, and we will make this recording as well as the slide deck and any outputs from this working group available to you after the event. Before we get started, I would like to quickly introduce you to all the speakers of today's events. And it's actually a little premiere, something we haven't had before because it was a small subgroup and every one of the people who participated in this group are actually presenting today. So that's quite special. So the chair of the working group, Yanni Papadopoulos from Jones Lang LaSalle, is going to give us an introduction and overview over the topic that they covered, the challenges, what was the mission they tried to accomplish, what are the key messages and recommendations they have for both the demand and the supply side, and basically looking at where the magic lies in how to deviate. Then we're getting 3 different case studies from 3 different states. We have Jean Davis and Dan Leong Scott from Sydney Water, who are presenting their case study that was done with John Holland Group. After that, we have Jonathan Chu from Lang O'Rourke, who's presenting on a project around the Victorian Level Crossing Removal Project. And then we have Yanni presenting again on the work that WM Main Roads has done around innovation processes around the introduction of crumb rubber in WA. And Les Marchand from WA Main Roads is also joining us for any open questions. And then just before we get into the panel conversation, CJ Williams will be taking us through an industry survey that the working group has run around this topic and the key messages that they picked up. Yes, so as I said, please do put any questions in the Q&A and there's an opportunity to upvote questions that you would like to ask them. And yes, let's get started. I'm handing over to Yanni. Yanni, can you turn your camera on and I'll be going offline.
Thank you, Kati. Hope everyone can hear me loud and clear. So today, we're very pleased to present our work that we've done over the last few months, looking at some case studies to show our industry how we can deviate to increase the uptake of LEC materials. The work we have done was off the back of some work that another subgroup had done earlier on, where they looked at deviation from a kind of process point of view, to put together a standardized process to help the industry try and navigate all the challenges of approaching deviations and getting stakeholders to approve and come along for the ride, whilst also demonstrating that new product, that new material that is low embodied carbon and how it can still achieve the same outcome as other materials that we're currently using or previously used. So our main challenge was very similar, and it was to try and overcome that lengthy and costly deviation process of justifying those new materials for use by projects in the construction industry, anywhere from small scale to large infrastructure projects, and trying to navigate those very prescriptive requirements that are typically established by organisations to enable consistent procurements. But we found that one of the challenges with that, it did prevent that or made that harder for the uptake of low embodied carbon materials. So leveraging that, we would decided our mission was going to be to develop these case studies and try and find projects across the country which did have some success in using the deviation process to actually drive the uptake of LEC materials, maybe at a project level, but also at a program or an organisational level. And wanted these case studies to identify those opportunities which can help us streamline that approach across the country. And so we're very careful and very intentional to try and find case studies, not in just the one state, but obviously, as Katja said before, we have case studies on the West Coast in WA, and also all up at the East Coast as well. So that was our mission. And so we wanted to, I suppose, cut to the chase and start with our key messages, share our key messages with yourself to start with, so you can start to bring these back into the conversations of the case studies as we go into them over the next few minutes or a little while. But the key kind of barriers that we kind of kept seeing pop up as we're developing these interview case studies and going through these interview processes with each of the organisations, well, there was a sense of fear that going through a deviation process would have achieved maybe a lesser outcome, maybe choosing a material that was a reduced performance or might have impacted the budget by being more expensive than the other conventional material, and even challenging the timeline of the project. So that was definitely a consistent theme that we saw pop up. The other theme was early engagement as a very, very big barrier to using that deviation process to apply to use a low embodied carbon material from the outset. Definitely a very big piece of work, that stakeholder engagement piece between the supply side and the demand side. And I should just maybe define just quickly demand side and client side, which I'm sure many of us would already appreciate, but demand side being the client side, those that are demanding those projects or procurement of materials, and the supply side being everyone behind the head contractor, contractors, subcontractors, consultants, designers, etc., or the industry that's providing that delivery of project. Another key message that came out was I suppose the idea of there wasn't maybe many KPIs and budgets allocated to actually enable those LEC materials to be explored during the projects, and that we saw as a real big barrier, where there wasn't that incentive for those project teams or supply side teams to actually spend that time to do so. Documentation. Surprisingly, we're relying a lot on data and information around these materials in order to put forward a very strong case as to why that low embodied carbon material can achieve the same performance requirements as another conventional material. And so we saw a common thread where there was sometimes, in many senses, many situations, limited documentation, whether it be not enough information about the material, not enough data, historical data to back it up as well. And the last one there, whole of life. I think we found that through these case studies, there was a general sense, of, particularly from the supply side, that there was a very project, the material in business case was looked at from a project lens only, a very short-term lens only, as opposed to the demand side being holding these assets for anywhere from 20, 50 to 100 years long. Those materials that are being put forward need to be able to demonstrate that there's a whole of life consideration for that, the duration of that asset. showing there's that benefit long-term, not just that initial upfront embodied emissions reduction and to offset the initial cost. So the main key messages that we withdrew out from these case studies, if you like. And so from that, we spent a fair bit of time putting together a list of key recommendations that we thought would help industry across both sides, demand side and supply side, start to position themselves or better position themselves towards using these deviation processes to increase the uptake of LEC materials. And so there's a bit here, and I'm sure everyone can read this on the screen as well. So I'll just kind of give a bird's eye lens to this. And again, really wanted to bring this up front. So then as we go through the case studies, we can start to, everyone can start to see how these case studies have identified these recommendations along the way. So the first key recommendation there is providing that incentive for LEC materials through that supply process or that procurement process. So when projects are being procured, having a clear requirement in specification or request for tender documents to increase the uptake of LEC materials. That's giving a really clear demand signal to the tenderers, the contract side, the supply side, to say, hey guys, we want LEC materials. Please allow time and to actually investigate those as a part of the project because we're receptive to them and we really want to hear about them. And that's really that incentive piece. There's a part there in terms of trying to have that, I suppose, enabling that collaboration, but internally as well. It's really important that we're incentivizing the supply side, but obviously there's definitely multiple parts within the demand side of the organization that we are needing to, that would be best to be communicating, collaborating everywhere from the team that's organizing the performance specifications for the organization, everyone through to the asset management of those assets throughout the 50 to 100 year lifespans, but then also the delivery teams internally as well. Having that continuous conversation across those three teams is really important, and having that incentive for those materials consistent across those different departments internally, we thought would be a very, very powerful way to improve this across the industry. Avoiding, so just jump into recommendation 2 there. There's a common thing that we found where we saw that because there are so many barriers to using that deviation process, we saw that there was a benefit in not relying solely on that deviation process. Using it, definitely, but we saw that it didn't work for every organization. And in fact, there was a case study which we'll go through where we saw that the deviation process was actually excellent for identifying new materials, identifying those new low embodied carbon materials, which can then be explored later on. So that was a really, really interesting insight. Also, we're conscious that there's a lot of smaller organizations that may not have horsepower internally to look at those low embodied carbon material applications, business cases, if you like, for the deviation process. And so looking at central bodies to help support those smaller organizations, as an example, smaller councils, maybe approaching local government associations for that support in that space. And lastly, they're looking at trying to use data in case studies to provide that confidence when organizations are receiving proposals for to try new low embodied carbon materials. There's plenty of data out there. There's definitely much more that we need. But there's heaps of examples of case study libraries there on the screen and databases that most of us would be familiar with that are great insights to where those materials would have been used in the past successfully. I suppose a bit more focusing on the supply side, engagement. Really, that's what we thought was really the key recommendation for the supply side, is really engagement and engage early. Projects obviously have a very tight timeline and tight budgets that we must, that everyone is really needing to drive an outcome within. And so things can slip away quickly when things are starting up, but that engagement piece early on is really a key step in that process of applying for a deviation to achieve a low embodied carbon material in your project. And so that might be asking the client the question, who's the key stakeholder to approve these deviations? What information do they need? And have that conversation early. So then when it comes to that time when it's ready to submit deviation, everyone's prepared, everyone has the right information, and it increases the chances for success for a LEC material in a project dramatically. So that's a very quick high-level summary of our recommendations. I don't want to drag that out any longer. So I think we're keen to jump to the case studies now. And the first one we do have is for Sydney Water. And as Carter said, we have 3 case studies. And in fact, we've got one which we looked at from both the client side, the demand side, as well as the supply side, which is really interesting. So I'll hand it over now to Dan and Jean.
Thanks, Yanni. Hi, everyone. My name's Dan. I work at Sydney Water. And one part of my role is to be the author and custodian of our deviations process. So I've just got a flow chart here on screen that shows the process at Sydney Water for deviating from our standards. Some of you may be familiar with this, others may not. I don't want to spend too much time on this, but I'll just briefly run through some of the key roles and explain a couple of the tie-ins to some of the stuff Yanni just mentioned. So typically we find that deviations from our standards are identified by a designer or contractor. We then have this step here, the initial assessment of deviations from standards. And the point of that is to avoid putting in unnecessary work where a deviation is quite simple or quite minor and the risks are low. So there's a step there where the project team, so that includes both the designer and contractor, the Sydney Water project manager, Sydney Water project engineer, which is the technical rep from our side for the project, as well as any other stakeholders, we'll discuss as a group and determine whether the risks are low enough to be able to proceed without going through the formal process. And so that's just in there to, to avoid unnecessary work on deviation requests. So the rest of this process only then applies when a deviation is substantial enough to require the full process. So when that is the case, the designer or contractor prepares and submits the request, which I'll talk about more on the next slide. They then send that through to the Sydney Water project engineer, the technical rep on the job, who has a look through to check the request is complete and reasonable. And that goes back to the point Yanni mentioned about having the right information at the right time. So trying to avoid going back and forth numerous times for more information. When they determine rather that it does have enough information, they pass it on to the standard author or SME, so someone like myself, who firstly checks there's enough information to undertake the review, and if not, goes back and asks for more. But where there is, we review the submission and provide a recommendation to either accept or reject it. Sometimes that has caveats, so quite a common pathway is to provide a recommendation for acceptance with conditions. That then goes to our project manager, who has overall accountability for the project, who then advises the designer or contractor of the outcome. A couple of points I just want to identify here. One is the potential for a feedback loop, sort of going around in circles in the review stage. We identified that was a concern on projects, and it's something I think that Yanni identified came up in the as part of this project. So we actually have a circuit breaker now in that, where if we're seeing a request go round and round in circles, the project manager has the option to at any point in time say, okay, this is it, we're making a call now, and what's the recommendation, and proceed from there. So that was something we did in response to feedback about that part of the process. And the other point I want to zoom in on here is just at the end there in the bottom left corner, where we talk about reviewing and advising on project outcomes. So a deviation request is typically something new for us in a lot of cases, and it's something we want to see how it performs, see if what was claimed and what was put forward as benefits in the submission eventuated. And so circling back around to the performance of the asset that had the deviation applied to it, gives us information on whether that can become part of our standards to avoid the need for deviations in future on that same topic. We have seen some examples of that, one which Jean will talk about shortly, where after successful demonstration on a project for a low embodied carbon material, we listed that material in our list of approved non-standard products. So it doesn't comply with our spec still, but it's listed as a product that can be used regardless because it's been demonstrated to perform appropriately. Next slide, please. So this slide just outlines the requirements of a deviation submission to Sydney Water, just to provide some context for the work that goes into it, which can be substantial in some cases. So the first thing for us is a justification. So for the designer or contractor to explain to us why we should accept the non-compliant solution and what the benefits are. So that includes things like sustainability, but also includes things like cost, performance, reliability, etc. And so part of that justification is to demonstrate that the proposed solution is fit for purpose. There's also an options and risk assessment, which is, I think it's an error in the slides there, but that's just done to compare the proposal against a compliance solution, as well as other options that might have been considered, and to look at the risks to make sure that what's being put forward doesn't introduce new and unacceptable risks for Sydney Water. We have a requirement for stakeholder engagement to ensure that stakeholders who are involved, such as operation and maintenance reps, are brought along the journey and have a chance to have their say. That avoids disagreements down the line about who was involved and who accepted things. And then we have verification and sign-off by qualified and experienced personnel. And the idea behind that is just having the same level of rigor applied to deviations, which are design decisions, as would be applied to any other design deliverable. And that's all from me. I'll pass on to Jean.
Hi, I'm Jean Davis. I'm also from Sydney Water. I'm a strategy and sustainability manager in our net zero portfolio at Sydney Water. So as part of our subgroup, we did interviews of different organisations based on their experience to develop these case studies. And as part of I interviewed John Holland from the supply side and interviewed Mark Trethway, who unfortunately was unable to be here today. So I'll be presenting from the supply side as well. So as Dan touched on, John Holland came to Sydney Water with a proposal for a high-grade compaction glass that could be used as a pipe embedment material, replacing natural sand, which that product contains about 40% or up to 40% recycled glass. And it has a reduction in carbon by using this product over a natural sand. So the Water Services of Australia Association of Australia has certain sand specifications for embedding materials and pipes. So the industry standards are actually based on the sieve size. So often the recycled material won't meet that requirement. And as a result, it will need trials if we're going to deviate from a different product. So this product was produced by Boral, and Boral had been working with Sydney Water for about 2 years prior to John Holland coming to us with this deviation request. However, with staff turnover and the handover of information, some of those records had been lost. However, Boral was able to provide some of that information, which did expedite this approval. So the deviation required trials. At different stages through these trials, there were certain phases that needed acceptance and then approval. But the overall approval took about 14 months. Once the trials were complete, the approvals took about 6 weeks for it to continue with that product. As Dan had said, that product has now been approved as a product for Sydney Water. But prior to this, the deviation was approved for just embedding in networks. So what was initially proposed was for pipelines and not for our water resource recovery facilities, which meant that another deviation would have been needed to be put forward if they were to be used on those facilities. And be it the trials wouldn't be as large, but it would mean that an additional approval was required. But as Dana said, that product has now been accepted as no longer as a deviation, as a product on our list. Next slide, please. So some of the insights that were provided from John Holland is that this project that they were working on was a very large project, and the people working, the project team, were very keen to deliver on the outcomes and get these low embodied carbon materials used on the projects. However, if it was a smaller project, the length of the deviation that it took to get this one over the line would just not be viable. And if cost was the only driver, when you think about your consultants, the testing, your staff's time, in doing the process, it also would not be viable. Clearly, we're doing this because we want to be using the sustainable outcome and the sustainable products and reducing the embodied carbons in the materials that we're using. And as I think Yanni's already touched on, there's that general theme, the fear of the unknown. It's a new product. What's the quality? Is it going to perform the same way? What are the risks that are associated with using that product? Is the deviation process included in the budget, and what effect does that have on the timeline of the project if you're using a new product as well? So we've touched on stakeholder engagement, but the stakeholder engagement's not just about that physical performance. It's also looking at the installation aspects. What were the safety concerns with this product? If it was, being glass, was it going to cut people? Were there other risks associated with the product, or dust, or something like that? The project team with the designers and the construction team to address the overall performance of the product. As Dan showed you on the flow chart, the different approval from the different engineers that are required. And then we also have previously touched on operations and maintenance. So will a different product require additional maintenance? Does it need to be replaced more often? And we talked about whole of life. What is the disposal requirements for those products when we're finished or completed with it? So one thing that became clear was that good record keeping is needed from both the supplier and the client side. And any delays in these approvals for the deviation is a lost opportunity for reducing carbon and the project having the overall benefits for the project. So next slide. So what were the recommendations that came out of the work that or the interviews with John Holland? And we keep saying this, early engagement, that's the main thing. We can avoid impacting the project schedule and also the lost opportunities of using the low embodied carbon. That is crucial to do that early in the process. Stakeholder engagement is also critical through this process. You need to get all the stakeholders on board up front, especially in big organisations like Sydney Water, and the feedback that we got from John Holland as well is that these big organisations, often you'll get one approval and then you'll find out, oh, but now might have been the engineering approval, now we've got to go to the safety. So if we can get all the stakeholders together up front and understand their requirements early, that will also streamline these processes and minimise any delays in implementing those products. So as I've just touched on, let's minimise the different number of approval processes that need to be undertaken. And I think Dan touched on that good record keeping. If we can get these low embodied carbon products, understand how they're performing and start getting the history, that then enables us to not have them as a deviation, to actually take those products in as a permanent product on our specification lists. And so as a result of that, encourage the client, people like Sydney Water, to do that whole of life product performance and gather that data as we work through those processes. Some of these products are very new, so we do need to track that to understand how they're going to perform, because as Yanni touched on, some of these assets are in for 20, 50, 100 years. So if we can build up those records, then we can start using those sorts of information to help with other deviation or similar products that will be used. Thank you. I'll pass on to, I think, Jonathan.
Thanks, Jean. Hi everybody. I'm Jonathan Chu. I'm a technical leader in our work winning business here in Melbourne, and I'm delighted to give you a bit of a case study here on one of Laing O'Rourke's projects in Victoria, and really a kind of good news story, if you like. So on the Southeast Programme Alliance, one of the level crossing removal project alliances, we were looking at a piling concrete mix with our project partners Vinci, Keller, and Holcim, and the idea was really to remove Portland cement content from that mix by having a really high SCM content of 70% in the mix. And that high SCM content mix would then allow us to achieve the overall project sustainability requirements of a reduction in greenhouse gas emissions. So that there was an overall project KPI to achieve a 30% reduction in that greenhouse gas emissions. So that's where the driver was to look at this concrete mix. I think our initial view was that as a project team in alliance with the client, our initial view was that the deviation was going to be needed because we weren't going to meet VicRoad standard 610 for acceptable concrete mix design. And we began the deviation process and a risk assessment. But whilst working collaboratively with VicRoads, which became DTP, we then found that we could actually avoid this deviation by obtaining their approval under a standard process that they had. And as I said, we did this fully in collaboration with DTP and getting each of our mixes approved. And meant that even though their standard was a 40% limit on SCM, we got sign off for this 70% mix. And I said at the start, good news story. And I think for me, we approved this mix for piling on one of our level crossing projects. And then it automatically worked with DTP for the next 3 projects within SEPA. And so overall, we found that about 50% of our concrete need was within piling, around 18,000 cubic meters. And by getting this mix approved, we went from 7,200 tons of CO2 emissions to 4,000. So, that was the good news story that I mentioned. I think overall, it needed that collaborative approach. It needed to work with DTP and across the alliance. But actually, the process taught us that we needed to go and, as we mentioned earlier in the presentation, go to the client early, go to the stakeholding bodies early, and really eke out where's the deviation going to be needed, or where could they start to accept a change to their standards, and go through an approvals process in that regard. So I'd like to hand over to the next case study. Thank you very much.
Thanks, Jonathan. So this is our third and final case study for today, and it is on the work that WA Main Roads has been doing with their deviation process. Now, we do have Les Merchant joining us as well, who'll be joining us for the Q&A, and I might even ask Les to help me explain and talk through the deviation process on the next slide in a moment. But I think just to first of all call out that when through conversations with WA Main Roads, we learnt a lot, and we saw that, in fact, their deviation process that WA Main Roads use is actually referred to as the innovation process. So first of all, I thought that's quite interesting, because innovation implies doing things differently, doing things better. And I think that's very testament to what we're trying to do here, using better low-embodied carbon materials. Now, I think through their experience using deviation processes in the past, they had found that the process was challenging to do within projects, because it did require extra time, did require extra cost, and sometimes it didn't provide the product didn't come to fruition. They may not have been able to achieve the certainty on using that material within the project process. And so they started to realize that they couldn't rely on that deviation, that innovation process all the time for the projects. And so what they informed us is that they saw the innovation process as a way to identify new LEC, low embodied carbon materials, that were entering the market, that were readily available, as a way to then inform them on what products they can start to become more familiar with and start to investigate outside of the project. And so that leads me to some of the work that they've been doing, a lot of work they've been doing outside of the projects at a program level, which is actually testing and trialing low embodied carbon materials outside of projects, and in particular a couple main ones using crumbed rubber in asphalt. And I think there was also another one using crushed concrete and aggregates as well. But taking that burden off those projects to achieve or approve those materials were worthy and doing them at a program level was a very interesting approach and has been very successful for them. And so they've seen the process, the deviation process, as differently to other organisations, which I think it shows this case study has some very strong lessons learned out of it that can be shared with everyone on the call and the rest of the industry, of course. Now, I think I might jump to the next slide there to zoom in a little bit on their process that they have developed and used. If Les you wanted to jump in after this, you'd be more than welcome to. But just wanted to highlight a couple of key things in this process they've been using. And first of all, they've obviously got a nice process flow with different stage gates and different decisions that need to be made along the way before getting to the final approval point. But what was really interesting that they broke down that and the business case, if you like, into really four core requirements that needed to be all addressed as a part of each business case: readiness, technical, regulatory, and suitability. And the regulatory and suitability are a definite yes. They cannot be bypassed whatsoever. If there are no, basically the proposal stops dead in the water. But the first two, their readiness and technical, is very interesting because it requires that there's an opportunity there to do extra levels of research and investigation and come back and then try again. But that's where that time piece does start to challenge project during the project process. But it also then shows that there's a technical element to demonstrating how those NEC materials can achieve the same performance outcome as standard materials. And there's that iterative approach and potentially some testing and experimentation required there, which is captured neatly in this process chart. Les, I might see if there's anything you wanted to add to that. If not, we can pick it up again in the Q&A.
Yeah, look, thanks, Yanni, and good afternoon, everyone. Look, I guess just an extra couple of points in there is this process works for small, minor innovations and can be very quick. But for more complex ones, we probably need to go through that research process, which usually involves a laboratory phase to prove things up in the laboratory. Everyone loves to invent something new and want a field trial. We generally don't do a field trial until we know what we're trying to validate in the field. So we need to prove things up in the laboratory, form a hypothesis, get our standards and specifications drafted for the new material, if it's blue sky material or new or something very different from our specifications already, before we go to a trial. And the main thing with this process is so that proponents, whether that's Main Roads, us as a client, or suppliers, they know what the process is up front. So there's no surprises that they get to the end and then find, there's a regulatory condition that no one had thought of. So this has worked very well because everything we've run through it, you can see right from the word go what you're going to have to get a yes or no on. And a key to this working, it's already been said by all of our speakers so far, is engagement. So get that early engagement, and it's interactive. So keep working through, get everyone on board through the whole process, including right through to implementation, and continue to foster it after implementation. So that's probably the key points I'll leave with there, and happy to discuss further in Q&A. Back to you, Yanni.
Thanks, Les. I think next up to speak for the industry survey is CJ.
That's right. Hi, everyone. I'm CJ Wilson. I am the sustainability specialist for Robert Bird Group. And I'm here to talk about an industry survey that we sent out. Not only did we gather the case studies, but we developed a survey that we sent out to the industry to try getting feedback on the different deviation processes that are out there and the experience of the industry going through those. So we got 17 total responses. We had a spread on both the supply side and the demand side, as well as a couple of people who wore a couple of different hats on both the supply and demand side. Now, the key messages, a lot of them are similar to the things that we've heard before, but there were some interesting points here. That industry is cautious about adopting new materials without at least 5 years of performance data. So the key piece here is, how are we gathering that data? And this is a question really out to the whole industry and everyone here on the call. You know, all these projects that are being done out in the industry using these new type of low carbon materials, how can we gather that information together so that way that information then can be used by other projects as evidence that this works well, right? So this is a bit of a hole within the industry right now that would really help moving forward low carbon materials as a whole for the industry. Limited policy incentives exist for LEC material adoption, and uptake often depends on proactive product teams and sustainability frameworks. You know, right now, this takes a lot of work to get across the line, as you saw through some of our case studies. And so it's really, you know, it relies on people who are very passionate. And it's great when you have those people. But let's say those people move off a project or there's a rotation, you can lose that momentum, and then that deviation process just withers on the vine, right? So without incentives to push forward this on a project or on a system level, you know, you may not be able to continue that traction to get it across the line and be able to make this a success. Clients are resistant to change. We all know this. You know, the construction industry is a risk-averse environment. But specifically, the risk is not shared well amongst the project team and supply chain. You know, often contract chains are set up in a way where the risk is just continuously moved around, and the contracts try pushing that down the supply chain. And if this risk all just lands on the builder or on the supplier, why would they do that? Why would they take that risk and try putting forward these low carbon materials if they're the one who could be buying the bullet if it goes wrong, right? We need to change the way we think about contracting and how that risk sharing can occur across a project. So it's more incentive focused than, you know, a punitive focused. Also, the time to assess and approve the LEC materials through a deviation process can be prohibitive to a project. You know, if it's a massive project where it has, you know, a year or two, okay, great. But there are a lot of projects out there that go a lot faster than that. And so how do we get across the line? How do we approach this process to shrink that process down to make it faster? And it's great that, you know, we saw, you know, both Sydney Water and Western Roads, they have created processes that create a really defined process. So that way you're able to check the boxes and there's no swirling. And I love the idea of a circuit breaker to allow something to just get moved forward instead of circling and circling and circling around. And so understanding that and creating that framework and creating that process that allows for a streamlined approach to get these through is super critical to be able to increase the adoption across the industry. And the last one, repeated submissions of identical deviations across projects creates inefficiencies and unnecessary workload. Let's be perfectly clear here. As an industry, we are burning money because of this repeated submission of identical deviations. And there have been plenty of scenarios that I've seen across the industry where a product was approved on a project, but then there wasn't the follow-up after the project to get that integrated into the specifications or into an approved deviation list. And another project comes on, it's a different team. They don't have experience with it. And it has to go through the entire process again, which is just a huge resource suck, right? So without that follow through and without doing that extra work and having that framework that builds into the system, like a systemic approach to this, we are just losing money left and right. So approaching this in a smart and efficient way will really help drive this stuff forward in the long run. That's everything I have from the industry results.
All right, thank you very much, everyone. We've got the last slide here as a quick reminder of the recommendations we had at the beginning, but I will stop sharing those now if you've had a last look at them, and would love to ask everyone of the panelists to turn their camera on so we can start having conversation. All right.
Perhaps I'll kick off the conversation by just an observation around deviations and the time that it does take for them. So recognizing, some of the examples here today have taken a long time, and recognizing that is an issue that we do see. We do see a lot of deviations go through very fast. However, it is often the big ones or the high profile ones that take the longest, often because they have potentially substantial risks or other reasons, like if they're a very new product. That's often the ones that take the longest. I think some of the data we have shows that most deviations that come through Sydney Water are processed within 2 to 4 weeks. I think, and when I say most, it's like 90%. But it is often these bigger ones. It's often the low embodied carbon ones, which are newer products, perhaps with less performance history, less industry knowledge about them, that can take a long time.
All right. Well, I'll go through the questions that have been submitted through the Q&A. One of those, the first one that was submitted, was relatively early on. From my experience, I find the business case for low embodied carbon products is hardest among sustainability initiatives. It cannot win on cost alone. What are the levers that you can use to support a business case? Anyone who wants to go on this? I think that was the Sydney Water case study that where you were addressing this.
Yeah, I can start, and maybe Jen can jump in as well here. But there was the comment made about how it's easier on major projects, and that's true for numerous reasons. One of which is that our major projects tend to have more stock put into sustainability. They tend to have more KPIs written around sustainability and carbon, whereas a lot of our more day-to-day projects just don't have that. They're structured, the contracts are structured around getting lower risk work done and done safely and fast. And so there's not the time given to those. So unfortunately, it does fall to the major projects to sort of take the initiative and get things moving, with the idea that then if those do get approved on those projects and we can demonstrate that they performed well, then they get into our standards and they get used across other projects. So not sure if I answered the question entirely, but unfortunately it tends to be around contract structures and incentives.
Right.
I've got another one. So right now we aren't yet in a fully resource constrained environment, but that is changing. Such as natural sand deposits are depleting, right? And so by creating these alternate avenues or supplies for your materials, you're actually de-risking future projects, because you already have an established pathway and a proof of concept for another material supply that you can feed in, right? And this is like from waste supply chains, right? There's also a increasing focus on circularity from a governmental standpoint. The government has stated that we're right now, I think, at a 4% circularity rate across Australia. The government has determined that they want to increase that to at least the global average of 7% and beyond that, right? So there's likely, along with that, going to start being incentive structures coming from government-led projects to increase the ability to be able to pull in waste streams. And those contractors who have experience already with pulling this information through or pulling these into projects will have a leg up in that scenario to be able to grab a hold of those incentives and make that much more financially viable and make that a win for their project.
And if I could top up further on what Dan and CJ are saying there, I think in the example that I gave from the SEPA level crossings project, you know, there were I said it in the case study, but there was a clear KPI on that project, so that's the lever. So that contract, as Dan mentioned, enabled the team to be focused on that as something that they needed to achieve. It was worthwhile for that project team to achieve that. And then they went and got the good news story that I mentioned. So I think it's the way that we structure the major projects and the industry around incentivizing contractors and designers to look for sustainable and low carbon materials. The better that we'll find the uptake.
Okay, fantastic. Thank you. So we've been talking about large projects here. There's a question that's come through. What can small and small regional councils do to who have smaller projects? How can they undertake the testing of materials? How can they give confidence to use new innovative materials? How can they get there? Do you have any ideas and recommendations you could share with them?
I mean, one suggestion would be to, if you have lots of small assets, so I'm imagining a council here with a large suite of road assets, trialing products out on one project, something perhaps a bit low risk, where a slight reduction in performance, say, wouldn't have major impacts. That gives you a chance to try out a product, see how it performs without applying it to your entire asset base and potentially wearing consequences if something does go wrong. Obviously, that's a slow thing to adopt because it would mean doing only one thing at a time, but that's potentially one way to build confidence. Another would be to draw on resources from other groups. Like, you know, we have, I think there's an organisation here in Sydney that represents a whole bunch of councils. Like, I think it's maybe a dozen or so councils across the southern part of Sydney. So if there are any council bodies or council groups that can work to pull resources, that also helps smaller organisations.
Yes, fantastic. Yeah, I'll add in there that with MECLA, we have just been working with a council in the Hunter region on trialling a lower embodied carbon concrete on footpaths to sort of get that sort of non-structural grounding trialing out there and raising the confidence with the council and their placing teams in the material, and obviously that ability to test the performance over a longer period of time as well.
Also,
yeah.
Something to kind of speak on top of Dan's point, I think alliances here are super key. So not just being trapped in your own, council, but relying on that systems level approach. I just became aware that in Victoria, all of Victoria is split up in this thing called the Victoria Greenhouse Alliance, where LGAs are grouped into groups of alliances, which, Jonathan, I don't know if you had mentioned this, but that creates a strength between where all the LGAs can share information and share resources and actually come at opportunities together to unlock opportunities that may be too risky for one council to achieve alone. And so there's, again, real strength in numbers. I think Victoria is really well set up. So if there's anyone on here from a state government level, look at Victoria and what they've done there, because it really allows and facilitates an ability to allow for that banding together to conquer these obstacles.
I'll
Pop in
jump
there
in.
if you. Oh, sorry.
No, you go, Liz.
Thanks. Look, each state has got its own local government association. So as has already been spoken to, so I guess working together in numbers does help, and you'll find certainly in the road industry that each local government association works closely with the state road agency to try and get some better synergy on doing research. And I guess in answer to both of those first two questions, it's getting that industry engagement. So individual local government authorities, if they're engaging an asphalt supplier, for example, Main Roads Western Australia works very closely with each of these industry groups. So part of the identification of sustainability initiatives, we want to be talking to the suppliers, and they should be talking to us. And that's what we encourage in regular meetings, to work out what are the joint sustainability initiatives which we can lock in and embed, and not just invent something new, but make sure we adopt it. And a lot of these things need to be mentored into business as usual. And for Main Roads Western Australia, it's really important that we work with local governments. So, for example, in the crumb rubber ceiling, we are assisting local governments. Any local government that wants to put down our crumb rubber ceiling, we've done all the research, we've done all the investment in getting that up and running, so the local government doesn't have to spend money on that, and we'll give them some support if they adopt. So there's a few things in there that work very well. So it's getting that industry engagement and getting the engagement with your other local governments and state road authorities or other state agencies.
I was pretty much going to say the same thing. I don't think they have to do it alone. That's probably the trick there. When we're holding these sorts of presentations or showcase, there's trying to get a better database of products that are available. We do have those examples that are there. It's, I guess, how can we actually get them out and help smaller agencies, get certain projects over the line. And as Dan said, I think you touched on footpaths or things that might be a lower risk in certain places or on certain projects. But we've got experience and knowledge in some areas. Is how do we share that so that we're not all going through the same processes all the time?
Yeah, great. So Les, you've already talked about how can governments help. WA Main Roads is doing that with the crumb rubber there. Another question that came in is, what roles universities can play to address these key messages? Do you see any potential for universities to play a role in this? And what would that look like?
Look, absolutely. And so we do engage with universities, and universities do engage with us. So if we go back to that flow chart, and something needs to progress to research and development, and we need laboratory, this is, if they're big items, this is a great opportunity for PhD students to basically share in doing their academic research, but also work with industry. So we have agreements with a number of universities where they come into our laboratories for a few weeks or a few months, and they get a hands-on for what the actual construction industry needs and the way a state agency works and specifications work, so they can make their research very, very pragmatic and focused on outcomes. So I think there's a huge role for universities to play. And I think it's really important for state agencies to be engaging with universities and vice versa. And I think that happens quite well under the ARC arrangement. So that we certainly have a very strong university engagement in Western Australia, where in concrete, in asphalt, in a variety of materials. So I think there's a huge role that universities can play.
Yeah, totally agree with what Les is saying. And to add to it, one thing universities do very well is follow through on scientific process. So one thing that we unfortunately see in industry is that people will propose something and propose a trial, but the success criteria around the trial are often not very well defined. Whereas at universities, you tend to see more structured research being done where there's a clear hypothesis and then clear criteria that get measured in order to understand the performance of a product. So look, if universities are doing research, it's just more evidence to support the benefits and I guess the use of a product. So there's definitely a role for there. Totally agree.
I think this also highlights actually a gap that we need filled. Les, I love to hear what you're doing at WA Main Roads, but I think you're going to see like 9 out of 10 contractors or project teams aren't raising their hand to the academic side if there's a gap in what they need as far as evidence or research to be able to get something across the line. So I think there is a really good opportunity here to be able to figure out some sort of centralized system that allows and facilitates ideas or concepts where there's missing gaps in research that allows universities to pick that up. So yeah, I think that would be a really interesting piece of work.
I think another comment there was university research. One of the things that sometimes annoys proponents of a really good idea when they come to us is the first questions we ask is, how does it break? How does it fail? We have to be, we need to learn to be a little bit more delicate how we ask that question, but you can't write a specification and a standard on how to make sure things work if you don't understand how they fail. So we have our laboratory here, so we are constantly trying to break things. Once you learn how to break something, wow, now you can put in criteria to stop it breaking when you actually use it in real life. And I think that's what universities can do really well. They can test those boundaries, keep trying, think of ways to break things, and then you can write controls in there so it doesn't break in real life.
Great. Let's look at the questions again. Here's one that comes out of a university. What is the likely acceptance of performance-based specifications?
Something we're definitely trying to do. A colleague in my team is working on, actually, it's something we're doing across the board currently, is trying to look at our standards as a whole suite of documents and see how we can apply that to reduce the number of deviations required, but also to avoid being unnecessarily prescriptive. I mean, ultimately, we don't really care too much about what's in a concrete mix as long as it performs as it needs to. So it's definitely something we're looking at doing. Sydney Water obviously has, I guess, the resources to do that for ourselves in-house. I'm not sure how it is for others, but yeah, it's definitely something that we should be pursuing across the industry, I think.
I think just to add to that, I think they might be, that really would support that first question, or kind of provide an answer to that first question. What's the lever? Well, you might not need a lever if it's performance specification. It kind of opens a door, doesn't it, to the, using those embodied carbon materials. Wouldn't it be great to see a performance spec that just has a, tons per cubic meter of carbon? Then that's the kind of the benchmark perhaps of that material. But it's something no doubt would need a lot of scrutiny before it's released, because obviously there's a lot of open doors to other things as well. So I think, yeah, that definitely ties in that first question as well.
Yeah, and I guess when we come to the question about acceptance of performance-based specs, it is a pretty big change in approach for many asset owners. Most specifications have been written and developed over many years based on things going wrong and how to avoid those, similar to what Les was talking about before with breaking things. We have seen things break and now we're writing specs to avoid them breaking. But because they're built around, well, in some cases around, what doesn't work and trying to address that, we often say, well, in that case, to avoid that, do this, do something very prescriptive rather than focusing on performance. So I guess the point of that comment is just to say that it is quite a big change in thinking for many asset owners. And so anything that we can do in groups like this to encourage that way of thinking is ideal.
I guess from a client state agency perspective, what we often see, so with, bridges and structures, we're looking for 100-year design life, and we're actually expecting a 300-year service life out of our bridges. So we have dabbled in performance specifications, but you need that whole of life cycle outlook. So with performance specifications or any specifications, we need to make sure that we're protecting the asset manager from not having to do increased maintenance interventions, which are all adding to the carbon footprint. So if you have a lower carbon footprint of material initially, we do need to prove up that material that it will have the durability to survive with little maintenance, and that's the best way to get to net zero emissions, is to have long life, long durability, reduced maintenance intervention, and simple ways pre-planned in advance on how you can extend the life at the end of the service life and reuse it. And it's very hard to capture that into performance specifications, but you know, it is something that we would all like to get to. It needs to meet all of those requirements, that it does give us confidence that we will get our service life, that we're not diminishing service life by adopting materials. And certainly crumb rubber, we've proven that you don't need to wait 40 years. We can prove this in 2 or 3 years in the laboratory, that we will get longer service life out of our spray seals and out of our asphalts and bitumens by adding those products. And we've done that by proving them up in the laboratory.
Great. So the next question I'm seeing here is, within those presented case studies, working with operations and maintenance teams, how would the deviations lead for the project build the confidence and manage the risks from an operations perspective? No one?
I can jump in. So that's a defined part of our process, to consult with stakeholders, including operations and maintenance. It just comes back to that comment about early engagement. You know, it's been talked about numerous times today, but getting out in front of it and talking to operations stakeholders as soon as there's an idea being put forward. A lot of the low embodied carbon deviations don't have major impacts. I mean, that we're seeing don't have major impacts for operation and maintenance stakeholders day to day. You know, things like service life and so on might, but things like the glass sand that Jean was talking about, different concrete mixes, aren't likely to affect our operations stakeholders that directly or that drastically. But it's still a requirement to consult with them, and bringing them on the journey is just part of the process. So we actually require, as part of the deviation submission, for the person submitting the deviation request to provide evidence of consultation with stakeholders. So that can be emails or meeting minutes or something. But as long as there's evidence being provided, then that's a requirement.
I think that there's also, it's important to have roles and responsibilities, and also, you know, dedicated timelines on the response period of those things. And also, like, really making sure that there's someone who's engaged from both sides, who are able to identify who are all the stakeholders who need to be involved from the get-go. Because the whole thing can be derailed if, like, all the perceived stakeholders are on board, but then, you know, for instance, the maintenance asset owner wasn't a part of one of those stakeholders. He gets wind of it, all of a sudden it goes back to square one because they have a couple questions that need to be answered, and it derails the whole approval process. So yeah, having clear roles and responsibilities, clear timelines, having that framework around it to keep it moving forward and on track. And then again, really, it can't be stated how important it is to make sure that all the right people are in the room, involved with the process from the get-go.
Yeah, totally agree with that point. Just to, I guess, on the point of response timeframes, I think that highlights another point, that it's ideal where possible to avoid lobbing emails back and forth. That tends to take a lot of time, and it tends to get missed, especially with operations stakeholders who are often out in the field doing other things. I suppose just encouraging people to consider engagement to mean not just sending off an email and asking for someone's input, but to really engage with them directly. Try to engage with them through meetings where possible, through design workshops where possible, but to really use all avenues possible to engage directly with people, not just via messages.
I think, Dan, from your the flowchart that you presented on expectations, I think having that up front as well, being very clear on each of the areas, what their expectations are that you've got to meet. So you don't want to do a trial and then come back and I think, CJ, you just touched on it, that you've missed the point of what the actual requirement was. Just be very clear of what the outcome from each of those groups, what those needs are. And as you said, as long as they're not going around in circles before you actually start, be very clear on what you need to deliver and demonstrate through that process.
Yeah, and if you do have a process that's like Sydney Waters or anything along the same lines, it's worth identifying, as CJ said, who is responsible for identifying stakeholders. That's really important. And so in our process, that's the responsibility of the project engineer, so the Sydney Water technical rep on the project. But that's a really key role, as CJ pointed out.
Okay.
So in most state agencies, and certainly in state road agencies, we have subject matter experts. And so I think that's pretty much the common term around the country. And it's those subject matter experts who control the specifications in their special subject area. And they are the ones who are responsible for consulting with industry and with asset owners to make sure that the specifications are keeping up to date and keeping, I guess, keeping up to date with not just products, but also with government decision-making on sustainability initiatives, that we are actively looking for lower carbon materials and making sure that we put in place funding, if need be, to research those materials that wouldn't otherwise get up and running. And that's the case with crumb rubber. Industry wasn't going to do that, so we invested the money in that space. Other areas like bio binders, it's the bitumen companies that are investing in that space. It's really important that they engage early with us, and we have used those products, but we need to sit down with the asset owners and convince them we want to put this on the road. We've tested it in our laboratory, they've tested it in there, we think it's all good to go. It's all about that engagement. It's engagement between within the client organisation on the asset owners for maintenance, the project managers on construction delivery, and the subject matter experts, then engaging with industry and suppliers. So that it can all be addressed in that engagement process, and you need to do it face to face. I agree. Emails floating around, you'll end up in a spiral. We have regular meetings with industry, regular meetings with asset owners, and we use our large projects where we set up technical committees on each project to work out what are the initiatives we're going to use on this project. Where did the last project, what milestone did the last project get to? You're doing this next step, because some of these materials do take 2 or 3 projects, unless like Sydney Water, you've got a very large project, but some of these initiatives actually do take 2 or 3 projects to turn into a specification for business as usual.
Great. So one question around here, and I have a feeling this is a huge question and would warrant its own event, is the thoughts on carbon accounting for low embodied carbon materials. How challenging is it to measure the emissions reductions associated with the use of a low embodied carbon material in the project? Does anybody want to have a quick shot at that, or
I think we can all agree that it's extremely complicated, and there are so many carbon calculators out there and they all give different answers. And this is a huge challenge for government. So certainly in the road space, we have been trying to get all the state road authorities together to adopt one carbon calculator for road building materials. So we've been working on that for a couple of years, and we're getting closer, and we're certainly getting more alignment. But at the moment, we can't even agree on what the carbon footprint of bitumen is, let alone, and the world can't agree. So Europe has got the same problem. So where the whole world is trying to identify what actually is the carbon footprint of bitumen. So we still can't answer the fundamental questions, let alone try and work out individual different products. We just had an international asphalt conference 2 weeks ago with European speakers, and their advice was, with carbon calculation, keep it very simple and make sure you are looking at the entire whole of life cycle. So not just your construction carbon footprint, but it is absolutely essential to look at your scope 2 and scope 3 emissions in that carbon accounting.
Yes, and I was being a little bit cheeky here. Alexi has put a link in the chat. MECLA might be doing something to talk about this. We do have a next event coming up very soon, which will be looking at different methods around carbon accounting, those carbon footprints you mentioned, or EPDs and whole of life cycle analysis and scope 3 reporting being mentioned in there as well. I think let's have a look at what everyone in this group, in this panel, the work of your working group is now finished. It kind of concludes with this. There's a more detailed version of this slide deck that you presented today that we will be putting up on the website along with the recording. Maybe any last ideas? What could next steps look like? What would you like to see happening in this space? Are there any final comments from you? Putting it out to you.
I will jump in the sense, I think we've touched on this several times throughout the presentation, and that is, how best do we move from deviations to that standard specification product? And that's obviously got to be that end goal, to have that faith. We don't want to keep going through deviations if we can avoid them, where we can streamline the processes and accept products for a overall program or within a corporation to accept them. That's probably the key, because the deviations can be consuming. No matter how streamlined they are, it still requires effort. So I think for just generally low embodied carbon, how can we just minimise that deviation expectation? But clearly there's a lot of steps to go through to get there. But that's probably the end state. Perfect world.
Does sound like an ideal world. I think hopefully we're not too far off, Jean. I think what I wanted to just add to that is, and as my final kind of comment for today was, I think we touched on a couple of times, testing and trialing, and how, there's not always enough resources in every organisation to be able to do that. And I think, wouldn't it be great in a perfect world where we can say, once one material is trialed and tested, that then everyone can then see the same information and be able to get the confidence that that can be used, and not feel like they have to repeat it and duplicate that testing. So maybe just a bit of a plug for the MECLA case study library to be able to share those case studies there, because in that way industry can get that visibility and that confidence that we're all looking for. So I'll leave it with that final comment. Thanks, Carden.
Yeah, the one thing that really became apparent for me going through this is the need for a centralized database tracking projects using low embodied carbon materials and novel materials. Something where a project can identify, hey, I'm using this material. And specifically, not only to identify, hey, I'm using this material, but also then to allow for tracking of that material over time as it gets into the operational period of that material. Something that a client side or a designer can hop onto, I don't know, a website or whatever it is, and identify, oh, this material has been used in this project, this project, and this project. Okay, we can actually take a look at real life examples of it and how it's handling in operation. Like, that is so key. If there's anyone with technical background or keen on this, I've heard this come up a number of times in the industry, and there's a lot of people who are like, oh, that would be so amazing to have, but it still hasn't actually come into fruition. If this is something that interests you, reach out to me because I'd be super keen to drive this forward. This is definitely somewhere that would really help the industry with these things.
I agree that these libraries and the MECLA libraries is another good resource. So sharing information is really important to being able to find that data. One of the things that I think is really important is I guess national industry groups. So things like the Australian Flexible Pavement Association, groups like the Cement and Concrete Association, other state road authority groups like Austroads, working together to work out and plan strategic maps on what are the next steps in each of our key areas. What should our focus materials be? What should our focus infrastructure be? And putting together a little bit of a strategic roadmap on what are the most important next steps, what order are we going to do them in, and that way we can leverage off each other. So you're not relying on repeating the same process on each project or in each state. We can actually then, if we start getting better engagement and more alignment, we can use universities, we can use Austroads, we can use each other to then get us to the next level up the ladder. And that's harder to do than it sounds, because each of us have got slightly different environments and materials. So it's really important that we find a way to align that and respect that there are slight differences in the maintenance regimes and risk appetites of different governments.
Jonathan, Dan, any last words? You don't have to. We're not forcing you.
I think I've said enough today.
I'm good. Thanks, Kathy.
All right. Well, thanks so much. I do hear a lot of themes repeating themselves here. One that always comes out is the engagement, the collaboration between all the different parts in organizations, across projects, but also across the entire system to get the first sort of deviation process going, to get every deviation process going, to get the process going through the entire organization, the entire project, and the entire system. So this is really what we at MECLA are working at all the time, trying to bring people together to make it and to share the findings and knowledge that we're gaining so everyone can benefit from that. So with that, I would love to thank everyone who's been working at this project, with everyone who's been presenting here today. Thank you so much for being part of this. As I mentioned, it will be shared. This event has been recorded. We will put this up on our website. Beyond that, I would like to thank all those companies that have now joined MECLA. We have over 200 organizations overall, and over 43 of them have now joined and made a financial contribution to keep us going, which is fantastic. And last but not least, I would love to thank everyone on the Secretariat, our chair, Hudson Worsley, our director, Monica Richter from WWF, and my colleague from Climate Kick Australia, Alexi Barnstone. Without you all, this wouldn't work. Without the participation of everyone in this network, it wouldn't work, and it wouldn't work without you watching this and asking wonderful questions. So please join us again on the 3rd of December for our next Spotlight event. And otherwise, I am handing you out into your early evening 6 minutes early. Thank you for joining us.